Okay, so generally what we're doing right now is transformations day 2, and we're studying changing the location of a graph. The size could also be changed. We're not doing that yet, though. So far, all we're doing is translations, which is like sliding them around. That's different than transformations, which can be also changing their size. And soon, we will be exploring reflections, stretches, and shrinks. And so basically, these parent functions are really important. And the 3 parent functions we've mostly been working with is x squared. I hope you remember that that kind of looks like the U shape. Square root of x, what have we been calling that? The ramp kind of shape. And then last is absolute value of x, which is what shape? That guy, what's that? A V shape. Good. Okay. And if we take those and do these things to them, stuff on the inside moves it left, right, and stuff on the outside moves it up and down. One more thing to remember, on the inside, things are the opposite of what you'd expect. That minus h seems like it should be moving into the negatives, like moving left. It does not move left. Minus moves to the right. So minus moves right. It's always counterintuitive on the inside, but normal on the outside. You can't trust anything on the inside. Kind of like this guy that I know that went to prison. He had an amazing on the inside story of he got put in the cell with this guy one night, and they just threw him in his cell because he didn't have a cellie. That's what you call your roommate. And his this guy that came was really kind of freaked out, and they had picked him up for driving a stolen car, and they threw him in the cell with my friend. And then he said, "Yes, I have a friend who went to jail. It's okay. It happens." And it's okay. That's all right. I'm not saying any names, but the person who got picked up and thrown in this cell had stolen a car. It's true. What the cops didn't know is he had also killed the 2 people that he had stolen the car from. And he knew that they were going to find out that he had done this. But in the meantime, this guy, he told the roommate, this friend of mine, everything. He told him the whole story. So can you imagine being in the cell with the guy who had just killed 2 people? They don't normally just throw them in with a roommate. You know, if they had just killed a couple people, they should be in solitary. But they thought he was just a stolen car guy. So anyway, don't trust anything on the inside. Okay, moving on. Another way to say it. On the inside, it did go somewhere. Slide left, and on the, let's see, plus on the inside goes left, minus on the inside goes right. On the outside, you're going up and down, and that's intuitive on the outside. Counterintuitive on the inside. All right, here is a parent function, the x squared. Absolute value of x, you need to know 5 points. These ones are pretty easy. And if you don't have at least 5 points graphed, you won't get credit. I saw some people doing this kind of an action on their homework. That won't count on the test. You've got to have 5 points and more. If you want more, you can have more. But then you can connect them with a line if you want to, but you need 5 distinguishable points, at least. Okay, moving on. The square root, the ramp, that one you don't have to have 5. I'm a reasonable person. You can't really get 5, because otherwise you'd have to go all the way out to like 25. So over 1 up 1 is a point, over 4 up 2, and over 9 up 3. Those 4 points are the ones you'd want for square root of x. Weird shape, that's what we're introducing today. You don't have to memorize that weird shape. The point is just that sometimes we just call it f of x. We don't know what the function is, but we know what its shape is. Is this truly a function? Yeah, as long as it passes the vertical line test. So here's a vertical line, and it never touches twice, so that's a function. Okay? All right. We'll talk more about that in a minute. If we're going to move this one, I will show you again the 3 ways that you would want to move this thing. You can either, get on this slide please everybody, you can either take the parent points here, grab them and move them. And you know how to do that with your iPad, right? You just circle around it, lasso it, and then move it 2 to the right, and then plus 4 means up 4. There, poof. There's my new graph. All right. If, that's one way. If you don't have your iPad like on a test, you can't really do that, can you? So in that case, what I would use is this other method, where you move it to the, you take the base, which you know is at 0, 0, and you just, in your head, you say, okay, I'm not even going to graph 0, 0. I'm going to move it 2 to the right and up 4. Here's where it should be. And then you recreate the 5 points from there. One on this side, one on that side. Over 2 up 4. Over 2 up 4. There, I've got 5 points. Third way, also a really good way. XY chart. Always works. If you want to graph even something really complicated, this will work. And on your homework, or on your test, when you get to this problem, please remember, the kids that try to do this by moving it to the right 5 and up 7, and then they try to do this stretch all in their heads, they don't get it right. The kids that make the XY chart, much more likely to get it right. And you say, okay, what could X be? I can pick anything I want to, so I'll pick 4 for X. Put in a 4 here. 4 minus 5 is -1. -1 squared is 1. 1 times 3 is 3. Plus 7 is 10. Figure out some points. 4, 10 is on the graph. All right, so don't forget the XY chart option. All right, everybody, try the second one up here, this square root of x1. Please graph that one for me. Graph the parent one, and then graph the child one, and then zoom in on it and show me, and I'll tell you if you're doing it right. I'm going to pause while you work on that. All right, so on this kind of problem, we want to take the dots and move the dots and connect those dots. So if it's a function that we haven't seen before, we just move the points in the same way we've learned, 2 to the right and down 4, and connect the dots. Okay, so turn your iPad my way so I can see yours. It should be 2 to the right and down 4. I can't see the new one. Connect the dots. Good, 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 good. Oh, gotcha. Gotcha. Good, good, good. I already get yours? Thank you. Good. Good, good. Okay, pretty much everybody's getting it right. Okay. So, we're moving on, because that was pretty easy. This would be the same idea. You just take the dots and you'd move it 2 to the what? Left, and then what? Down 3. I don't have to do that one. That's too easy. Okay, let's talk about domain and range. That's on your little mini quiz too, so let's make sure you remember it. Okay, so if I take this graph and I'm going to move it 5 to the left and down 1, so it's the parent one, I'm going to do it this way. And I'm going to grab those points, and I'm going to move them 5 to the left. There we go. And then down 1. Boop. There it is. Okay, that part's pretty easy. What's domain and range? Well, domain is left to right. Range is up and down. And some people get that, okay, they get the big concept that it goes from negative infinity to positive infinity. And that's correct. But then they forget some of the little details, like, okay, well then what's range? What if it doesn't go to infinity? Well, then you say what number it does go to. So if we're talking about range, it's this way. And always go from the smallest number first. You cannot write this backwards and say that it goes from infinity to -1. You have to say -1 to infinity. And I've done one more little mistake. Anybody notice it? Mr. J. Yes, -1 needs a bracket there because it touches at -1. So this needs to be a bracket. Okay, any questions on domain and range first before we move on? Okay, then writing an equation. If I was going to write an equation for this one, I would say absolute value of x up 4. Okay, that's on the outside. Plus 4. That's it. Done. Easy. If I was going to do this one, y equals x squared, I'd say here's an x squared, and then I'd try to figure out where to put the 3. Should I put on the inside or the outside if it's going to go right 3? The inside, so here's right 3. And yet I'm amazed at how many kids are going to get this wrong. Try the third one, and then tell me what you get. About half you're going to get it wrong. We'll find out. Okay. Maybe it's not half, but all right, I'll tell you what I'm talking about. Yeah, it's not that complicated. You got square root of x, and then up 5 means plus 5, and then left 2 means plus 2. Well, what's wrong with that? This is wrong. There's no y equals. Equations have to have an equal sign. Burn people on that in pre-calc all the time. And that's because when you get your test graded in AP Calc, if it says equation and you don't have an equals whatever, it's not an equation. This is an expression if it doesn't have this. This is an equation. Okay, good. Most of you had that anyway, so it was less than half the class. The blue graph is the original. Write an equation for this purple graph. Well, how are you supposed to write an equation if you don't know if it's squared or absolute value or cubed or what it is? Use F. Try to write an equation for this. I know it's been, and just in case it's hard for you to count from the back row, it's down 5 and over 3. Well, how do you write the equation for it then? How do you always start if you have to write an equation? Y equals. Okay. Then, if you don't know if it's squared or whatever, what do you put if you don't know? F. And then you just say to yourself, okay, there's always an x in here, and now it's moved which way? Right 3. And then down 5. There you go. You put an F in it. All right. Last thought. If you had to put one function inside of another function, f of g of x, can you tell which one's inside the other one? G is the one that went into the other function. So g should go into the other function. And the only place you could put it is x. So you take this function right here, and you write it with an empty spot where the x is. I recommend parentheses. And then a minus 1. Notice the minus 1 is not underneath the root. Then what do we drop in? X plus 2. And there we go. Now isn't that just a move to the left 2 and then down 1? You recognize it now that we put it one into the other? Probably wouldn't hurt to have a y equals at the front here. It looks just like all the other ones we just did. Maybe that extra parentheses is freaking some people out, but it shouldn't. It's just a square root, and you got a plus 2 on the inside, so that's moved to the left 2. All right, I want you to try this one. Put the one function in the other function, and tell me what function you get, and then graph that function. G's on the inside, so this one is going to go into that one. All right, I'm going to take this function and write it with an empty spot. And I'm going to drop the other one in there. Empty spot. And then I'm going to put x plus 4 in there. Now, some of you probably didn't follow my advice and put the empty spot in. And then here's what they do. They go like this. You see what happened to that 4? It's now outside. It shouldn't be. that x was all underneath the root, wasn't it? So have an empty spot where the x is supposed to be. This will really help in pre-calc too. Whenever you're dropping one function into one other function, you definitely do that in pre-calc. Have an empty spot for x. Drop in x plus 4, and there we go. Now, do I really, now that I'm done, have to keep the parentheses? No. But they were really helpful to keep you from making that little mistake. Okay, then it's just the square root function moved 4 to the left, and so here's a rough sketch of it. Looks something like that. Except something 5 important points, or 4 in this case. 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. See, I went a little high with my first estimate. There's the best answer because it's got 4 distinct points. Raise your hand if you would have had that one right. Okay, good. Then to sum it up, the translation, it's you moving h units horizontally and k units vertically. Does that k in the front kind of annoy you? Annoys me. I'd rather have it where? At the end. But if I just put a plus k here, it's the same exact thing. They're just trying to show you that it can be in the front. That's okay. It's all about inside and outside. The stuff on the inside moves it left, right. Stuff on the outside, up, down. All right, your homework looks like this. We're having this little quiz in a moment, but you can go ahead and get into your homework if you want to while I'm handing these out. This little blue quiz is due in about 10 minutes, and we're going to grade it in class. That's all I got for the video.